All right, so just a quick recap on what I was talking about. I was talking about cardinality. So let me just begin all over again, just to get a clear view of what we're talking of here. So we're talking of cardinality. Cardinality of a set is just the number of elements. So cardinality is just the number of uh, elements that are in your set, and it's denoted as n a like this. So the number of elements. So if I have a set, let's say my set A is equal to 1, 2, 3, and 4. So the number of elements in these sets, I can count them, which is 1, 2, 3, and 4. So NA of this set is just going to be equal to what? To 4. That's the cardinality of this set. Then I have the other concept here. They're asking for two things, cardinality and power set. So power set of a set is just the number of what? Of total subsets that you can make in that set. So what are the subsets which you can have? So that includes the empty set and the set itself. So one thing you should always remember, the empty set is a subset of every set. Empty set is a subset of every set. Every set you have. This empty set is going to be a subset of that set. And the set itself is the what? Is a subset of that set. So the way I have these elements listed, these 1, 2, 3, and 4 are going to be what? The set of, or are going to be a subset of that set. So like I had here 1, 2, 3, and 4 will be a subset of the set A. So now let me try to list down subsets of A. What are the subsets of what? Of A. Let me try to list down all the subsets that I can list down. So a subset, of course, is, I can be talking of subsets and we don't understand. So a subset is just a set contained within what? A set. A set contained within a set. I always give an example, diagram. And this diagram here has these two sets inside. I have A and B there. And I have A containing 1, B containing 1, and there's 2 there. So the set A itself, if you can see, the set A contains 2 elements, that's 1 and 2. Then the set B contains what? The element 1. But I see that 1 is also a member of what? Of A. So meaning B here, as you can see, B can be contained in what? In A. So meaning B is a subset of A. So B is a subset of A. So now a power set is a set containing all possible subsets of that set. So now let me check all possible subsets now. So let me list for this A here, what are going to be all the possible subsets, including the what? The empty set. So if I was to see, the power set of A is going to be equal to, now let me list down there. Okay, first let me list down the power set, just the subsets on themselves before I list it out like this. So I have the subsets that I have the empty set, 1, then I have 1, 2, 3, and 4, which is the set itself. Set containing elements just 1 itself, set 2 itself, set containing 3 itself, set containing 4 itself, and I have set containing 1 and 2. So I have set containing 1 and 3. Then I have the set containing 1 and 4. Okay, I'll end here. So they are going to be a lot. You can list them out like this, but they are given by a formula where you just say the power set of A is going to be equal to 2 raised to the power n, where n is that the cardinality. N is the cardinality, which is the number of what? Of sets that are there. So the number of sets, as I can see here, okay. So what is the power set of this set here that I listed? This set here. So say P of A, and P of A is equal to 2 to the power n. What is my n? So my n here, from this here, I found it is 4, and I have 2 to the power 4. So 2 to the power 4 is just going to be what? This is going to give you 16. And so meaning the power sets that I have, or the power set of this of this set contains what? Contains 16 elements. Contains 16 elements. Okay. Or 16 subsets. It has 16 subsets. Now let's do the ones in the question now. The ones given in the question. So the ones given in the question, I have A, and A is equal to, there's 1 there, and it contains, so the set here 2, 3, and that, and it closes. So the set A has 2 elements. It has 2 elements, the element 1 here and this set here. So the elements, remember, are listed just by what? Separated by a comma. So I have 1 comma and that element there. So the other element there is what? Is a set. So cardinality, number 1, I find the cardinality of A. So which is just the number of elements. The number of elements is 1 there and this other one. So there are 2 there. So 2 is the what? Is the cardinality. Then they're telling me now the power set, and write down the power set of each of these. So now the power set of A, which is given by 2 to the power what? N, is going to be 2 to the power 2, and 2 to the power 2 is what? Is just equal to 4. So meaning the subsets that sit there are what? Are 4, and I can list them. So I can list them. That is, first of all, the empty set. Then I have the set itself. So the set itself, that's 1, and the set there 2, 3, like this. This here is a subset. Then I have now the one where I just contains 1, like this. And I have the other one where it contains the set containing the set 2 and 3, like this. Okay, and I can close it off there. Okay, I don't know now. Do I have any questions? I want to hear from you. Is this clear on how we find the power sets and how we list down the elements there? Is it clear? Okay, as I said, feel free, just unmute your mic and ask. If you've remained behind, that's the purpose why we're having this live session. Just unmute yourself and ask. I'll attend to that question. All right, since we don't have any question, I guess it will come at the end. Let's do the one that follows. So the one that follows B. So B contains 3 elements. That's 1, 2, and 5. So I've answered it in the first part. So the cardinality N of B here is just going to be what? To be 3, because it contains 3 elements. The power set, which is given by 2n.
I have a question.
Yes, you can ask a question.
Yeah, can you like start over? Because that's when I joined. Can you like summarize from where you started from?
Okay, so you mean with this question?
Yes.
Okay, so with this question, what we're doing, and I'm sure you get it more as we do this one and see. So what we're doing with this question, we're finding the cardinality. So this term here, which you are seeing in the question, whether it's stating you state the cardinality. The cardinality of a set is just the number of elements that are in that set. So in this set B, as we are seeing, there are elements. There's 1 here, it's an element. So 1 is the first element, then 3 is the second element, then 5 is what is the third element. So I can count this. There's 1, 2, 3. So meaning 3 is the number of what? Of elements that are in my set. And that is the cardinality. And the cardinality is given by this here. That's writing number of elements B, and it is 3. That is the cardinality. Then now we have the second part, which is talking about the power set. The power set, by definition, a power set is just a set containing all possible subsets of what? Of that set. So I have the set B here. So all possible subsets. So first of all, I have to define what a subset is. So a subset is a set contained within another set. So I have a Venn diagram here. Let me use the Venn diagram. So I have this here, like this, and I have A, there, and I have B there. Then I gave a simple example to say, let's say I have an element here, the 1 contained here, and I have an element 2 and 3 contained there. So if I was to list down the set A is just going to be equal to, so the set A contains 1, 2, and what? And 3. Then the set B contains the element 1. So this one here, I can also see it in the set A. The one which is in B is also in the set what? A. So meaning this B here can be contained in what? In A, as even shown in the what? In the Venn diagram. So B is a what? Is a subset of A. B is a subset of A. So now, what we are talking of now, let's go back to power set, is that the power set is a set that contains all possible what? Elements of that set. All possible, I mean, all possible subsets. All possible subsets. So all possible subsets. Okay, sorry. So all possible subsets of that set. Including, so we must now, including, so the set itself is part of it, is a subset of itself, because it can be contained in itself. So including the set itself and also the empty set. And I said that the empty set is always a subset of every set. That is a rule you must know, or a law you must know. So the empty set is a subset of every set. So that is what a power set is. A power set just contains all possible subsets of that set, including the set itself and the empty set. And it's given to know the number of possible subsets. You use this formula where you say 2 to the power n. So now 2 here to the power n, from this where we're saying n is the cardinality. N is just the cardinality, meaning n is just the number of elements in that set. So this is just going to be, in our case for B, 2. What is the one n? Our n is here, we found to be 3. So 2 to the power 3 is just what? 2 to the power 3, this here is just going to give you 8. This gives you 8. So meaning the total number of what? Of subsets that I have is what? Is 8. I have 8 possible subsets. Now, they're telling me to list there, to state and write down the power sets. So I have to write down this power set. So the power set A is going to contain what? So I need to list the subsets that are there. So I can start always, the empty set is always going to be part of that. So I know 1. Then the set itself is always being contained there. Those 2 conditions I must always remember. So 2, I have to list the other 6. So the other 6 now, I can first list down the elements themselves, just 1, the set containing 1 only. So that's 2. Set containing 3 only, that's 4. The set containing 5 only. So I have 1, 2, 3, 4, 5. So these are listed 5, meaning I have 3 more to go. So 3 more now, which is I can have the set containing 1 and what? And 3. Then I can have the set containing 1 and 5. Then I can have the set containing what? The set that contains 3 and 5 only. 3 and 5 only. Then I can close that there. So now this here, as I can see, there's 1, 2, 3, 4, 5, 6, 7, 8. So it has agreed with what I found, that I have 8 subsets that are in my power set. So that is how you find the power set there. Okay, now let's do the last one. So if you understand the last one, meaning you also understand the first one, which we did. Okay, so the last one there, C. So what does C say? So C is equal to, it's a set that contains the elements 2, 3, and this element, which is a set 3, 7, and I close there and I close. So when it comes to sets, even if you have another set contained here, you just treat it as an element because it's listed in this main set which you have. So the set C has elements 1, 2, and 3. So I can write that as and C like this to be equal to, so the cardinality of this set is just 3. Then what is the power set now? So the power set of C is just going to be 2 to the power n, and our n there is what is 3. So 2 to the power 3. And this here gives you 8. So I have total 8 subsets that sit there. So I can list those subsets now. So P of what? Of P of C, I mean, P of C. What are those sets? So I always start, you can always start with the what? With the empty set. Because the empty set is always going to be there. And go to the cell, to the set itself. So the set itself, I have 2, 3 there, and that's 3, 7 like this. So I have the 2 there. These are the subsets. Then I get the next subset. So the next subset, I'll get just the elements themselves. So the elements that I have 2 only. Then I'll go and say 3 only. Then I'll go and say that the set containing the set 3 and 7 like this. Then I've listed them now, just the set itself, like each element as a set. Then from there I can now group them, where I list, maybe I list 1 and I list 2 and 3. So I list the set containing 2 and 3 like this. Then I can list the set containing 2 and this other element here, which is a set. So 6, 3 there, 7. Then I close that set there. Then I can have now where I list 3 and this one here. So the set containing 3 and this set here, which is 3, 7. Then I close the set and I close that set there. So I'll have this here. So as I can see, that's 1, 2. So I have 1, 2 here. Let me use white so that you see as I'm counting. I have 1. I have 2 here, 3, 4. Then I have 5, 6, 7 here, and I have 8 there. So meaning this set here has what? Has fulfilled that there are 8 subsets, and I can close that there like that. So this is how I find the power set and list down that power set. Okay. Do I have any question here before we do the last question? Then we close, call it a day. We're behind time. Okay, so the next question here says, suppose S. So suppose S, as you can see, saying suppose S is equal to this. So this is just the set of OX such that X is an integer and X is in between. There are 2 and 7. So I can list down the integers that are there. So 2 is not part of it because there's strictly here a less than symbol. But 7 here, there's an equal to, so meaning 7 is part of there. So meaning when listing this set S, I'll start listing. Oh, and I'm also answering already the first part of the question because the first part is asking us to express S in roster form. And roster form is just listing. So we can list those elements. So when I list them, I have 3 there. The next integer is what? Is 4. I have the next integer there is going to be 5. I have 6 and 7. They've told me 7 is part of that interval. So 7 is going to be part of there. Then they're telling me find the cardinality. Cardinality is just the number of elements in that set. So n, S like this. The cardinality of that set, I can count what are the elements there. There's 1, 2, 3, 4, and 5. So the cardinality here of S is just 5. Number of elements is 5. Then they're telling me how many proper subsets does S have? How many proper subsets? Note down the question, proper subsets. So a proper subset, this is a set that, so as we're denoting, saying that I have B contained in what? In AI. So a proper subset is a set that is contained, of course, it's a subset, but it does not contain all elements of what? Of A. So if I have the set, so I have the set 1, 2, and 3. So I can have the set 1 like this. This is going to be a proper subset. The set 2 like this 2 containing, this is going to be a proper subset. So it must not contain all the elements that are there. So meaning that there's only one set, meaning that if I say this is the set A, meaning B should not equal to 1, 2, and 3. Because if if B is equal to these elements, like this 1, 2, and 3, meaning B contains what? All the elements in A. And for it to be a proper subset, it must not contain all the elements in A. So that is the condition. And now, how I find that subset is, so I do the same as I am find the same way I find the power sets. So the way I find the power sets, so in finding power set, I'm just saying power set. So power set of S, we say that is S to the power n like this. But now when it comes to finding the proper subset here, what you do is, so I'll indicate proper subsets like this, and I'll say what you do, you say 2 to the power n, but minus 1, because I know that there is that one subset. Is that one set, that one set that cannot be not contained there for it to be a proper subset. So this would mean the cardinality still remains here, which is 5. So 2 to the power 5 minus 1. So what is 2 to the power 5? 2 to the power 5 is just 32. Then minus 1. And this here is going to give me 31. So meaning there are 31 proper subsets of what? Of S. 31 proper subsets of S that can be there. Okay, so this marks the end of this class. I don't know if do I have any questions. Is anybody lost?
I have a question.
Sure, you can ask a question.
For the first one there, when listing, why do we not include the 2 in the question?
Okay, so for the first one here, why we did not include the 2, let me just erase this. So, okay, you can now mute your mic. Yes. So,
Okay.
so why we do not list 2? So when they're listed like this, interval like this, let's say if it was like this in this form. So when there's the less than sign, what this interval here is telling you is that x, the values of x that x is taking up, are just in between 2 and 7, and it's strictly less than that they're using here. Like it's just strictly what is in between there, meaning that 2 and 7 should not be part of that listing that you're going to have there. But when we have an equal to, let's say if we had equal to here x and also there equal to 7, meaning 2 and 7 should be part of that listing there. There's an equal to. So when something, meaning it can be in between, just in between, or including the boundaries that you have, which is 2 and 7. So including the boundaries, what? 2 and 7. So if we were to list this one here, this one would be, start from 2, because then they're talking of integers. So 2, 3, 4, 5, 6, and 7. So this is this one. And this one, which is strictly less than, then the integers in between there are 3, 4, 5, and what? And 6. So this is just strictly like that. But in our question, it is one-sided. The boundary is what? Is one-sided. So one-sided, what I mean by one-sided, as you can see here in our question there, the equal to sign is only where 7 is and not where 2 is. So meaning 2 is not part of there because there's no equal to sign. Meaning if I start listing, I will leave out 2 because it's not part of there. So meaning I'll start to at 3, then I'll go 4, 5, 6. At 7, there's an equal to, meaning 7 is part of that one. So I have to include 7. And that's the reason why I start at what? At 2 and all the way up to 7. Is that clear? Do you have further questions on that one?
It is clear.
All right, thank you. Do I have any other question from anyone?
Sir, I have a question, please.
Yes.
So for the last one, where they say how many proper subsets does S have? I wanted to find out in the formula that you used, why do we have 2 to the power n minus 1? Why are we putting the minus 1?
Okay, so the formula that I used, as I said, so I indicated PR to just indicate proper subset. Then, and I was using S, and I said 2 to the power n, like this, minus 1. Okay, so first of all, our key understanding must be on a proper subset. So a proper subset of, so we're talking of S now. So the proper subsets that S must have. So first of all, remember the cardinality. We said the cardinality is just the number of elements that I know that are in the set S. And in the set S, we have only 5 elements in this case. So now, let's go back to, before we talk of proper subsets, let's go back to the power sets. So power sets of what? Power set of S in this case would be given by 2 to the power n, where n is the number of elements in the set. And this here, the power set of S, will just give you all possible subsets you have, all of them that you have. And if I was to write this, this would be 2 to the power 5, and this gives me 2 to the power 5, that's 2 by 2 by 2 by 2 by 2, 5 times, that's 2, 5. That is going to give you 32. So 2 to the power 5 is 32, meaning I have 32 possible subsets, 32 possible subsets that this set can take up. Now, notice that for a proper subset now, when we're talking of proper subsets, let me now go to what we were saying. So a proper subset is just going to contain, so a proper subset contains, does not contain, so these are sets that are contained in this set. So they are subset, of course. So a proper subset is a subset. So if we talk of S, so S, the subset of S, for example, 3 is a subset of what? Of S. When I list 3 and 4, this is a subset of S because this can be contained in what? In S. But proper subset means it does not contain all the elements of what? Of S. So I know that there's going to be only one element, one set, I mean. There's going to be one set that will contain all the elements of what? Of the set. And that is going to be what? The set itself. So if I have this set that I have, which contains the elements 3, 4, 5, 6, and 7. 3, 4, 5, 6, and 7. This is what? It's a subset of itself. And it contains what? All the elements that are what? That are in S. So proper subsets are subsets that do not contain all the elements that are what? That are in S. So meaning it has to have some elements that are in S. And there's only one of these sets that is going to contain all the elements that are what? That are in S. That's the reason why I introduced now the minus 1 to this formula here. To remove that set, such that this now qualifies for me to know how many proper sets, how many proper subsets I'm going to have. And now, to know, since I know that the total number, like I found before, total number of subsets that I have, 2 raised to the power 5 here minus 1, where 5 is what? Is just the cardinality. And then I get here 32 minus 1. So 32 is all possible subsets I have. But now, from the possible subsets, I am going to remove that set that contains all elements, since a proper subset does not contain all the elements that are in that set. So if I remove that one set, then I just remain with what? With 31 sets. So these 31 sets are subset of S, but do not contain all the elements that are in what? In S. So this is why I use this formula here. I don't know. Is that clear? Do you still have questions around that?
It's clear, sir. The only thing I wanted to ask was, do we utilize this rule of 2n minus 1 every time we see proper subset, every time we see a question that has the word proper subset, or does it vary?
Okay, so when they're asking, in this case, they're asking for the number, like how many proper subset are there. So you always use this formula, because it won't vary. You always just have to remove one of them. Yeah, so that is how you get it.
Thank you.
Sure, you're welcome. Do I have any other questions from anybody else? All right, so it's silent, means everybody is on page and we've understood. I'll try to share the written solutions to this. Yeah, I try to share the written solutions such that you can go through the answers as you are solving on your own, just to check them out again. All right, thank you for attending. I'll see you next time in the next class as we continue. So I said to those, if like the tutorial sheets and what you're doing in class, yeah, you just update me always. Like update me. This is what we're doing. We might be having a test, maybe or a quiz this coming month, such that we kind of look at the questions compact in order to prepare maybe for an assessment or so, and also just to be updated with everything. So I'll try to finish up with this tutorial sheet, but if not, we don't finish with this one, I'll just send a recorded class, like it's going to be catering the other questions that we want to solve. That's if they post another tutorial sheet before we finish this one. All right, so that's it. Thank you, guys. If you're new, remember to subscribe and share the link with others that are able to also access this information. All right, I'll see you in the next class.